Hi, in this short demo I'm going to show you how to implement a reverse Polish notation calculator. We'll just do the first few steps, and the goal is to introduce you to some of the main concepts of the Glamorous Toolkit. First of all, we're going to start by programming in a playground. So this is a notebook where we have named or unnamed pages with code snippets and text. So this one is going to be a stack machine with for reverse Polish notation calculator. And we'll just start immediately by coding in the notebook, and we're going to create an instance of our stack machine. So this is going to be an instance of a new stack machine. So this is a code snippet that we can execute here. Of course, the stack machine doesn't exist, so that's why we have this little fix-it here. So we're going to create a new stack machine, and here a template will pop up prompting us to create a stack machine as a subclass of object. That looks fine. We'll give it a package name, and then we're pretty much done. So let's create that. Now we can evaluate this code and inspect the resulting objects. So this is something we see over and over again in Glamorous Toolkit, that we have these inspector views. So whenever we evaluate an expression, a code snippet like this, we can inspect the result. In this particular case, we don't get a very interesting view. The raw view just shows that the only instance variable is self, so it doesn't actually have any state yet, so it's not so interesting. The stack machine should have some state, and it would be cool, for example, to have some place to store the value of the stack. So let's create an initialization method. So we switch to the meta view, which shows us the code. The methods, there aren't any yet, and we'll just create an initialize method. Oh, that's not what I wanted. Initialize. And we commit that, so we have one method. Let's do a super initialize first, and then we'll say that the stack should be an ordered collection. And of course there is no slot yet, so we'll create the slot and we'll accept that. And here we see there's a new slot called stack. This instance, of course, wasn't created with that initializer, so we have to evaluate it again. So now we get a nice new clean stack machine object. And what do we want to do with the stack machine? We'd actually like to, oops, excuse me. Let's write a little bit of text to explain what we're going to do. We have a stack machine for our calculator, and we want to have keys to press. We're just going to build the model now, so we're not actually going to build a nice user interface for our reverse Polish notation calculator. And then afterwards we might eventually get to a nice user interface, but we're just going to build the model and get it working. We'll write some tests, and we'll have we'll have at least one dedicated view, custom view for the inspector. So basically the idea is the following. We have a stack machine and we want to press keys. So we'll need a method for pressing keys. I'm just going to pick one. I'll say bang. So if I say bang, that means I'm going to bang on a key, and I'm either going to send it a number, and a number will be pushed on the stack, or I'm going to send it another key, which is some operation to perform. So let's say we want to push the value 3. So obviously the method bang isn't implemented yet, so we'll create this method, and the key could be anything, so it could be an object. But if that object happens to be a number, then we want to push it. So if true, then we will self push the object. And we'll worry about the other operations later. Obviously, the push method doesn't exist yet either, so let's implement that. So here we have the push, and we're only going to push numbers. So we're going to push a number. And how are we going to do that? Well, we'll say self stack add last a number. And actually the stack should have some accessors, so let's just create them. So they're there now. Okay, so this should be working. So if we evaluate this, we can see in the raw view that there's a stack, and the stack has been updated. This is kind of ugly though, this view. If we dive into the stack, we see there's actually an items view, and that view is kind of nice. If we option click on this, notice that we have a tree view, we have boxes, we have a bunch of other views for ordered collections. I'm not going to waste time programming something that's already there. So if I option click on the items view, I can see the actual source code. So the source code looks like this. I could copy and paste this, but what I can do instead is I can just forward requests for viewing our stack machine to the ordered collection. So I'm going to do that. So right here, I'm going to, in the meta view, I'll create a new method, and I'll call this GTStack for a view. So this is a view, a custom view. So whenever we open an instance of a stack machine object, we'll get an additional view to the raw view. And all these methods look the same. There's GT something for, it's an arbitrary name, and it takes a view as an argument. And it has to have a pragma, which is GT view. And then they all look the same. We take the view and we send it a message indicating what we'd like. I can never remember this. I'm just going to look for the senders of forward. There are all sorts of implementations here. I'm just going to steal some of this code because it looks pretty close to what I want. And what I'm going to do is the title of this view should be the stack. And we'll give it a priority. That's the order in which we see these views. So I'll say it's 10. And the object is going to be a self stack. And the view that we're going to leverage is GT items for. So the moment we save this, presto, the view is available. So here we see our stack machine. It has a nice stack view. And if we now push 4, well, it's not updating immediately, so that's kind of annoying. So what we'd actually like is we'd like to have this view being updated automatically. Now, I happen to know that there's an update method, but it only works if we have an announcer. And I also happen to know that there as a wrapper around collections, which is a collection value holder or something like that. So maybe instead of initializing this to an ordered collection, we want an ordered collection as value holder. And this guy is an instance of a collection value holder. Here we see all its methods. So it's going to be something when we add something to it, the announcer will say that the value has changed. So we can leverage that now. Oh, I should really create a new instance of this guy. So now instead of having a collection, there will be a collection value holder. And now if we add 3 to it and add 4 to it, it's still not updating automatically, but we'll fix that now. So here's our source code, and what we want is update when value changed in our self stack announcer, and that should be a block. So let's look at that again, and this time it's now updating nicely. Great. So let's add some operations. So what we would like to do is we'd like to be able to say, if we send it a symbol, then that symbol should be interpreted. So for example, plus, if we bang on the plus key. Of course, right now nothing happens because that's not implemented. So let's have a look at the bang method. We can look at it here. So if it's a number, then we do one thing, and if it's a symbol, then we could do something else. And otherwise we just ignore things. So in this case, we'll want to do something. So let's do the object, whatever it is. And of course we have to implement that. And this time we know that it's a symbol. And well, what should we do? We should look this symbol up in a table where we say for every key that we bang on, which method it is that should be executed. So we should look that up somewhere. So let's do self operations at a symbol, and if that's absent, then instead we will do nothing. And we should perform this, right? Oh, sorry. Let's make that. Ooh, that's weird. Self-perform. That looks good. Of course, the operation should be defined, and operations, that's just going to be an accessor. So return operations, and that's going to be a slot. And gee, we should initialize that. So operations, initialize operations, and that's going to be pretty straightforward. We're just going to create a dictionary. So let's see, the only one we have for now is the plus operation, and when we execute it, we want to execute the plus method, which we don't have yet, and that guy should be a dictionary. So let's implement the plus method. Oh, we also need to implement do nothing. Okay, and there's the plus method. What do we do in the plus method? Well, we should grab the top of the stack and the top two items in the stack and pop them off and add them together and push that. So let's say self stack pop. We're going to do a self push of self stack pop plus self stack pop. And we'll need a pop method. And we'll just return self stack remove maybe that'll work. Where's our stack machine? Let's inspect that guy again. Here's our stack machine, and let's see if this works. Oh, it doesn't. Right, because we never initialize this guy. So let's initialize him so we get a new stack, and this guy has the operations which are initialized. And now we'll do add a 3, and we'll add a 4, and now we'll run the plus. Oh, but it didn't know what pop was. Why doesn't it know what pop is? Ah, yes, of course. Plus should do self pop plus self pop. Right. And there we go. If we try to do that again, of course, that shouldn't work. But we could add a bunch of other things to the stack and run them one after another. Oh, that's looking pretty good. What we would like now is actually we'd like to have some tests for this thing. We didn't write tests in the beginning, but we're going to do them pretty much the way you would write any other kinds of unit tests, except that our tests are going to be encapsulated as examples. So let's make some examples. So we're going to start with a stack machine examples class, and we'll create a new empty stack machine. This guy doesn't exist yet, so we're going to create him. He's also in the RPN package. And empty doesn't exist yet either. Now, this is going to be two things at the same time. First of all, it's going to be a test case, but it's also going to produce an example for us. The way we do that is we're going to use a pragma called GTExample, and we're going to create an example. So let's call it result for the moment. And this is going to be a new stack machine. And it's going to be temporary. And we're going to return it. We would also like to assert something. So we'd like to assert, for example, self assert that result stack is empty. And now we can run this guy. So just like ordinary tests, we get a test that's green. But in addition, we also get an instance back. So this is an instance of a stack. Here's our class. It's got a bunch of examples that we can run, and each of them will return a value. So let's take another example. New push 3. And this guy is going to look similar. But what's interesting about this is that instead of creating our fixture from scratch, we're going to leverage the one that we already have. So this time we're going to start with an empty example, and then we're going to hit bang on the 3 key, and we'll assert that the top is 3, and we'll return that guy. We'll try and run it, but of course that's going to create an error because top isn't implemented. We can dive into the inspector and into the debugger and run, and we'll see that result top equals 3. Top is not understood. So we can go to the stack machine and we can implement top here. And then we can continue executing. And there's our example. Now we can add some more examples. So push 3 and 4. And it's going to look pretty much like this guy. So let's just steal that code. Push 3, and we're going to now push 4. And the top value should be 4. That's looking good. And push 3 and 4, and plus. And we'll create that guy too. Once again, the code's pretty similar, boilerplate code. So, whoops. Something's wrong here. And this time, push 3 and 4. And now we'll hit the plus key. And finally, of course, we could test other things like that the size of the stack is whatever. And that's looking good. We had one little piece of garbage here, so let's remove that. We also can see the examples map, which shows that these examples are built one out of the other, or we can just run them individually and see what states they're in. Of course, for any given example, we can evaluate it and explore the state of the stack machine that results. Okay, that's everything that I wanted to show you at this stage. Of course, we can add more operations, and we can add a fancier user interface. We can add different kinds of views. We might, for example, want to add different kinds of views, keeping track of the history of the stack machine and go back and forth in time. But this is more than enough for the moment. Thanks for listening.